On this video, we're going to see how to evaluate a logarithmic expression. And in order to do that, we have to write it in exponential form. And we know that to write it in exponential form, we have the relation between the elements of the logarithmic and the exponential. So if we have logarithm base 9 of 81, the base on the exponential has to be the same. You have to have a 9. And you're asking pretty much 9 raised to this exponent, an unknown exponent, needs to give you, so the exponent will be there, needs to give you the value that the expression is using as argument, so equal to 81. So what is that exponent that would make 9 an 81? The exponent needs to be 2. So that is the answer to this evaluation. Now, let's do just a few that you can find here. So the base on this one is 7. So 7 needs to be raised to this exponent, unknown, to be equal to what we have here, the argument of the logarithmic expression. So 7 raised to the power of 10. Because both have the same base already, and we just want them to be equal to each other, the only thing that this one is missing is a 10. So the answer is 10. Now, what happens if you have something like this? 3, that's the base. We want to find the exponent that would make that exactly 1 over 27. What I usually do when I don't have a very good idea of what's going on, I try to write both with the same base. So 1 over 27 can be written as 1 over 3. 3 squared is 9, and 3 to the third, it'll be 27. 1, any value raised to the power of 0 is 1. So I can write this as 3 raised to the power of 0 divided by 3 raised to the power of 3. And whenever I'm dividing two things with the same base and an exponent, it'll be a subtraction. So this is 3 raised to the power of 0 minus 3. So this is just to remind you that 1 over 27 is 1 over 3 to the third power, and that's equivalent to 3 raised to the power of minus 3. So this will also be equal to 3 raised to the power of minus 3. So that means that the exponent I'm looking for is minus 3. And let's do another one over here. The base is 3, and we want to raise 3 to this exponent to end up with the square root. Let me use green to keep the pattern going. 3 raised to the power of 5, but we're getting the square root of 3 raised to the power of 5. So we have to keep in mind that any radical can be written as a fraction. So if we have the square root, that is equivalent to having 1/2. If you had the cube root, it would be 1/3. And when you have two exponents, so 3 raised to the power of 5 and then raised to the power of 1/2, you have to multiply the exponents. So this is going to be 3, and 5 times 1 is 5 divided by 2. So instead of writing the square root of 3 raised to the power of 5, I might as well just write it as 3 raised to the power of 5 over 2. So that means that the value I'm looking for is 5 over 2. And the answer here is going to be 5 over 2. Now, what do we do on this one where we have a base 4? And we want to get Let me write it with green. We want to get a 2. So 4, how do we get a 4 to turn into 2? Well, usually you can think of 4. Now we're working with the other side. 4, in order to be equal to 2, we need to get the square root of 4. The square root of 4 is 2. But instead of writing it as a radical, I'm going to write it as 4 raised to the power of 1/2 gets me a 2. So that means that the exponent I need here is 1/2, and that will get me the answer over here. And we're going to do this one finally. 3, we're looking for an exponent that would turn a 3 into 1. And as we have seen several times, that exponent needs to be 0. 3 raised to the power of 0 will get you 1. So your answer will be 0.